This is video 1 from Unit 3, Lesson 2. Okay, so now we're going to talk a little bit more about functions and function notations, and then finally write some function rules. Okay, so first of all, a relation is just a set of ordered pairs. So it could mean any set of ordered pairs Okay, so it can be any set of ordered pairs. -8, 6, 9, 20, 4, 500. Doesn't matter. Any set. A function is where a relation is a relation that assigns exactly one output value for one input value. From before, remember, our output is the range, the input is the domain. So I talked about this in the last lesson. So remember, your input, you have a function like y equals 2x. Every time you put in -1, what are we going to get? -2. So you only, that should say -2. You only have that one output for -1. You're only going to get -2. All right, function notation. So function notation is this f, you've probably seen it before, parentheses x. So what this means, when you see f parentheses x, that's saying the function of x. We pronounce it f of x. It is not f times x. It is f of x, meaning function of x. It is the same thing as y. It's just a fancy way to write y. It's kind of like the difference between cursive writing and print writing. Y is like the print writing, f of x is like the cursive writing. So if you see this, we could also write that like this. F of x equals 3x plus 4. So f of x, just like y, is the output. All of this is the output. X is still our input. Okay, I want to determine whether the relation is a function. Use a mapping diagram. So mapping diagram is kind of like a table. We make two columns. So we have our input column, which is x, and here we have the output. The only difference between this and a table is that they don't have to match up side by side. So let's just look at our inputs. 3, -2, 0, 2. I'm going to put these in order from least to greatest. So I have -2, and then 0, and then 2, and then 3. Okay, let's look at our output. 6, 1, 4, and 6. So I'm going to put these in order as well. That's 0, 1, 4. Oh, I'm sorry, I messed up, right? 0 is an input. Okay, so let me start that over. I have 1, 4, and 6. And I won't write 6 again. Okay, so I just now match these. This makes it a mapping diagram. So up here, -2 goes with 1. So I'm going to match that, draw an arrow there. 0 goes with 4. 2 goes with 6. And 3 also goes with 6. So your output repeats. You have a 6 that repeats. That's okay. Your input cannot repeat if it is a function. So this is the column I want to look at. As long as none of these numbers repeat, then yes, it's a function. Because that means all of these inputs only have one output. So even though that the 6 is used twice, the input was different. 2, 6, 3, 6. 2 and 3 are your input. They still only had this one output. And this is what a mapping diagram is. So this whole thing, that's our mapping diagram. Another way to tell if something's a function is the vertical line test. So the vertical line test says if any vertical line passes through more than one point of the graph, then for some value of x, there is more than one value of y. Therefore, it is not a function. Okay, so what we do is we go ahead and we graph these points. So this is a 10 by 10 graph. Mark that so we know our scale. Okay, so 4, -2. 1, 2, 0, 1, and -2, 2. What I'm going to do is draw vertical lines through each of these points and see if it hits, if any of my vertical lines hit more than 1. Now, all these vertical lines only go through one point, so that means it passes the vertical line test. So yes, this is a function. Okay, let's look at the other example. Again, this is 10 by 10, so every line is just 1. Okay, 3, 0. -2, 1. -3, 2. And 3, 2. Okay, I want to draw vertical lines through these. So what happens is that this vertical line, just this one, went through 2 points. That means that it failed the vertical line test, so it is not a function. So if it goes through, if a vertical line, any vertical line goes through more than 1 point, then it is not a function. It fails the vertical line test. I'm going to look at just a few other graphs. So Let's say we have graphs that are connected. Let's look like at this graph here. These are arrows. And I want to check my vertical lines. So no matter where I draw a vertical line on this graph, and I know my hand drawing is not that great, I'm not going to go through the graph more than one time. So this is yes. This is a function. Okay, let's say I have the graph of a circle. I know that's not a very good drawing. If I draw vertical lines through the circle, most of the time it's going to go through 2 times. And it can't go through more than once, so this is not a function. Okay, so we can do a mapping diagram or vertical line test to tell if something's a function. Let's start talking about function rules. So function rules are our equations, so like what's going on in the table. So first of all, we have to know that my x's, my inputs, are going up by 1s. So if they're going up by 1s, then what I really need to look at is my y column, my f of x. Remember, f of x is a fancy way of writing y. Alright, so let's look at the change and what's going on here. So between 5 and 6, adding 1, so 6 and 7, adding 1. 7 and 8, adding 1. Okay, so this number that you add or subtract every time, this is what goes with x. So in your equation, so I'm going to start building this equation. Because what I'm going to have is f of x equals something times x plus something. Alright, so what we add or subtract to y, that's the part that goes with x. So 1x. Now, what I put in the second blank has to do with making this table true. So right now I have this function, f of x equals 1x. I haven't added or subtracted. So if I plug in 1 for x, my output is 1. But when I plug in 1 for x, I want to get 5. So what do I need to add to 1 to get 5? I need to add 4. So now this equation will make this table true. Let's check it. Let's plug in 2 for x and see if I get 6. Okay, 1 times 2 is 2. 2 plus 4 is 6. I check 3. So remember, this left side is just y. I'm just noting I'm plugging in 3. So 3 times 1 is 3, plus 4 is 7. And that's what I'm wanting. So my function rule is this right here. F of x equals 1x plus 4. You know, sometimes when it's 1, we don't write the 1. We would just write x plus 4. Okay, let's do that a few more times. Okay, again, in all three of these tables that I have here, x is just going up by 1, so I only really need to look at y. And let me write out my blanks here. F of x equals blank x plus blank. So the first blank comes from the change in y. Let's see. Looks like I'm adding 1. So 1x. All right. So now let's go and plug in this 1 here. So f of 1 equals 1 times 1. I'm plugging 1 in for x. And I need to figure out what do I need to add to that or subtract to get negative 1. Well, 1 times 1 is 1. So to get to negative 1, I have to subtract 2. Okay, let's make sure that works. So try 2. I want to get 0, and I did. So here is my function rule, which could be written 1x as x, and then plus negative 2 could be written as just minus 2. So this means the same thing. All right, next one. Okay, let's look at the change in y. This time I'm not just going up by 1s, I'm going up by 2s. So that's a 2x. All right, if I plug in 1, I'm supposed to get 2. 2 times 1 is 2. Okay, so what do I need to add to 2 to get 2? 0. Oops, should be 0. Let's check the next one. 2 times 2 plus 0 does give me 4. Okay, so this is my answer. So sometimes you won't see that plus 0, so it could be written f of x equals 2x plus 0. Okay, let's look at this last one. Why don't you pause and see if you could figure this one out. Okay, so we're going up by 1. So 1x. If I plug in 1, I want to get 3. 1 times 1 is 1. So I need to add 2 to get 3. Let me see if that works. One times 2 plus 2, that equals 4. Okay, so I am good. Okay, you're now ready to do Unit 3, Assignment 2.